Now we're going to take a look at inequalities where we have a constant to the power of some exponent with a variable, except the bases on both sides are different values. So in this case we have a base of 3 and a base of 5. To do this, we take the log of both sides. So take the log of the left, 3 to the v plus 1 power, and the log of the right, log 5 of v, or 5 to the v power. Once we do that, we're going to look at our exponents, our v plus 1 and our v here, and we're going to move those as coefficients out front, because when we have logarithms, we can do that. So let's just take that v plus 1 and make it just a coefficient out front. Take that v, make it a coefficient out front, and multiply it by our logs, what remains of our logs. So the handy little property of exponents, or of logarithms, that will allow us to solve this inequality. At this point, we have a v plus 1 times log 3, which is just a constant, just a number. We're just going to use the distributive property here. So we'll have v times log 3 and log 3 times 1 here. So v times log 3 plus just log 3, because it's times 1. Still greater than, our sign doesn't change here, we're not doing anything that would change it, v times log 5. At this point, I want to get all my terms with v over to one side and my terms without v over to the other side. So I'm going to subtract the v log 5 from both sides and subtract log 3 from both sides. And then we have our two terms with v in it over here and our constant over on the right. Again, sign doesn't change. Now I'm going to factor out my v. So I had a log 3 times v and a log 5 times v with a minus sign in between. So log 3 minus log 5, all of that times v. And that's still equal to negative log 3 on the other side. Last step, you just take this part that's times the v and you divide it on both sides. However, because we're dealing with inequalities, there's something that you need to look out for. If you were to punch this in your calculator right now, log 3 minus log 5 is negative 0.22, and negative log 3 is positive 0.477. Excuse me, negative 0.477. And when you divide both sides by the term next to v here, when you divide both sides by negative 0.22, you're going to have to switch the sign because it's in an inequality. Whenever you divide by a negative in an inequality, you switch the direction of the sign. So over here, even though you can't tell that you're dividing by a negative, you are. That's why when we set up this equation, when you divide this on both sides, you're going to have to switch the sign. The only way you can really know that you're doing this every time is to take this value right before you divide, the value that you're going to be dividing by, and check it in your calculator. So in this case, I would have just punched in the log 3 minus log 5, found that it was negative, then gone ahead and wrote it in the exact form while switching my sign. And then we take our calculators out and we can get an exact answer. V is less than 2.1507. Now you'll notice here I got slightly different answers between these two, and that's because of rounding error. So that's why, even though you could evaluate it over at this step here, technically you could evaluate it all the way up here when we have constants, but the reason we like to keep it in exact form until this very last step is because otherwise you start to accumulate lots of rounding error. Next example, we have 1/2 to the x power is less than 3 to the 1 minus x all over 2. Now in your original problem that you see this written as the square root of 3 to the 1 minus x. Remember, the square root power is just the same as the 1/2 power, so I just took the entire power that they gave me and divided it by 2. So, going forward here, we have different bases. We have exponents and variables in the exponent. So we take the log of both sides, log of 1/2 to the x, and log of 3 to the 1 minus x over 2. At this point, we want to move those exponents out front so that we can work with them a little bit more easily. So the entirety of the exponent, that means the 1 minus x over 2 over on this side, are going to get moved out front as coefficients. Once we have it here, then we need to distribute. Before we do that, just to make it a little clearer, I'm going to break this up. So I'm going to take this fraction here of 1 minus x over 2 and break it up into 1/2 minus x over 2. And just split that. So now we're going to distribute on this side. We're going to take 1/2 times log 3 and negative x over 2 times log 3. And now we have everything split up into separate terms. The terms that I want to get together on the left side are my terms with my x's in it. So I'm going to get these two terms over onto the left. So I'm going to add this to both sides. And once I do that, I'll have x log of 1/2 plus x over 2 times log of 3, still less than 1/2 log 3. Scroll down here. Factor out my x from both of these parts, and I'm going to have an x, and left over I'll have log of 1/2 plus, remember this was just 1/2 times x, so 1/2 log 3, still less than 1/2 log 3. The last step is to divide. We take this entire side and divide it out so that we get x by itself. But again, we want to make sure that we're not dividing by a negative number. So if you punch in log of 1/2 plus 1/2 times log of 3 into your calculator, you are going to get negative 0.0624. So that's all multiplied by x, and then on the other side, 0.2386. If you divide through by a negative, we switch the sign, we switch the direction. If this number had come out slightly positive, we would not be switching the sign. You don't always switch the sign in an inequality, only when you divide by a negative number, which will happen sometimes, but not all of the time. So if we put this in our exact form, we have the 1/2 log 3 that we had in our numerator, still here, and we have the log 1/2 plus 1/2 log 3 that comes into our denominator. Punch all of this in your calculator now for your exact answer, and you're going to get x is greater than negative 3.8188. Again, you can see the rounding error if we evaluate too early. When we did this one and just took these numbers, divided them by each other, you get rounding error. So that's why we want to keep it exact. And again, you remember we had the sign one way, and we divided by this negative constant, even though it was in a different form, still had to switch our sign. And that is solving inequalities with different bases.